Hello students, once again I am with some numericals from last year JEE questions. Topic is fluid mechanics expression. So let's go to the first question. The question is a soap bubble of radius 3 centimeter is formed inside another bubble of radius 6 centimeter. The radius of an equivalent soap bubble which has same excess pressure as inside the smaller bubble with respect to atmospheric pressure is dash centimeter. Difficult questions, big questions, but if you go the questions thoroughly, repeatedly, if you don't understand, you are not getting the questions at one go, just repeatedly read on the question again and again, you will find that this question is not that difficult. It's very easy one. What it's saying, let's first draw a diagram. Whenever it's necessary, always draw the diagram. A soap bubble of a radius 3 centimeter is formed inside another bubble of radius 6 centimeter. That means a soap bubble inside another bubble. This is radius is 3 centimeter, and the big bubble, the radius is 6 centimeter. Then the radius of an equivalent soap bubble which has same excess pressure as inside the smaller bubble with respect to atmospheric pressure is dash centimeter. That means there is another equivalent soap bubble which has same pressure inside, same excess pressure inside as that of the excess pressure of the smaller bubble. So this is what given in the questions, that this equivalent soap bubble has the same excess pressure inside it which is equivalent to the excess pressure inside the smaller bubble. Then find the radius of the question asking to find out the radius of the equivalent soap bubble. So here you need to find out the radius of the equivalent soap bubble. So now it says here, so just what you need to do, just find out the excess pressure of this soap bubble, equate it to this equivalent soap bubble, then find out the radius. So what is the formula for excess pressure inside a soap bubble? That is equals to 4 times of the surface tension upon the radius. Now for excess pressure inside this is the excess pressure. So excess pressure inside the small bubble will be how much? 40 upon R1. Pressure inside this one is 40 upon R1 plus, as it is inside a bubble which is again a soap bubble, its excess pressure will be 40 upon R2. Bubble inside a bubble, so the pressure originally due to this bubble is 40 upon R1. Then since it is inside another bubble, that pressure will also be exerted on that bubble, so the total pressure will be 40 upon R1 plus 40 upon R2. Now what this is equals to? This is equals to the excess pressure inside this equivalent bubble. So excess pressure inside this equivalent bubble will be how much? 40 upon R equivalent. Now we can equate this as per the question. So this is 40 upon R1 plus 40 upon R2 is equals to 40 upon R equivalent. So all this get cancelled. R1, R2 given, that is 1 upon 3 plus 1 upon 6, that is 1 upon R equivalent. So this is equals to 1 upon 2, 1 upon R equivalent, that is equals to radius of the equivalent soap bubble is equals to 2 centimeter. Easy one. So just don't go afraid by reading the question in one go. Repeatedly again and again read the questions, try to understand it. You will find that most of the question is not that difficult as you understand from the first reading. Okay, now let's go to the second question. In this question, a diagram, a figure is given in the question booklet. And from this question, what it's saying, the water tank has an area of 0.4 centimeter. There is a water tank which has area of 0.4 centimeter. I am just writing what is given in the question. Area of this water tank is 0.4 meter square. The tank has an opening B near the bottom whose cross section is 1 centimeter. Now again at the bottom there is an opening B and its area of cross section is 1 centimeter square. 1 centimeter square. So here the area is 4 meter square, here the area is 1 centimeter square. load is 24 kg is applied on the water at the top when the height of the water level is 40 centimeter above the bottom. So when that means at the initially when the water level is at that much, that is equals to 40 centimeter, a load of 24 kg is applied at the top. That means weight is equals to mg is equals to 40 kg applied at the top when the water level is at the height of 40 centimeter. The velocity of water coming out of B is V meter per second. So here the velocity of water coming out is V meter per second. Then the value of V to the nearest integer is how much? So what the question is telling, that there is a water tank and there is an inlet at the bottom. In the figure it is given like that. So water is coming like this and ejecting from the hole B. Area of water tank is 0.4 meter. Area of this hole is 1 centimeter. A load of 24 kg is on the top and the height of this water level is 40 centimeter. Then find the velocity of B, which is equals to V. So you need to find out the numerical value of V. So that's the question basically. So water is flowing. So what equation you can find out to find out the velocity? Equation of continuity or the Bernoulli's theorem. So here there are two cross sections are there, two area of cross section, two velocities. So just put the Bernoulli's equation. So what is Bernoulli's equation? That is equals to pressure energy at one point, that is pressure energy at A. Suppose this cross section is A and this cross section is B. So the pressure energy plus the potential energy, that is equals to rho g HA plus half rho VA square is equals to pressure of B plus rho g height of the this cross section B plus half rho velocity of B square. So this is Bernoulli's equation. So what is given and what you need to calculate? The pressure at A and pressure at B. This is rho gh and the velocity. This you need to find out. So velocity of these terms are missing. So let's first calculate this. So what is that pressure at A? What is PA? What is pressure at A? So here your load is there, that is 24 kg. That means a force is acting in downward direction plus atmospheric pressure is there. So that also acting in downward direction. Now due to this, there is inward pressure in the liquid which is acting in the upward directions. So that means there is a net force acting on these regions from which you can find out the pressure at region A. Downward force, upward force, balance these two to get the force which can give you the pressure at the cross section A. So to find PA, let's say to find PA, so let's say that is the downward force mg plus the atmospheric pressure, that is equals to PA is equals to the upward force. Force is equals to pressure multiplied with area. Let's say pressure at A is equals to P and multiplied with, this is atmospheric pressure. Let's denote this as P naught. Atmospheric pressure P naught. So here also atmospheric pressure is there because it's open to the atmosphere. And here the pressure at A. PA multiplied with A. So this we only trying to find out the pressure at the region A. Okay, so what is that pressure at A? Pressure at A would be mg upon A plus P naught. The atmospheric pressure A will get cancelled. So this is the pressure for the region A. Now what is height at A is given, that is 40 centimeter. So what is height at B? Height at B, that is equals to, from the figure it's very clear, that is 0, it's at the ground level. So height from the bottom level is 0. So here the height is 0. So this term can be cancelled. So what is pressure at B? Pressure at B will be the atmospheric pressure P0. Now VB, that is denoted here as V. So simple, you just need to find out this V. So now let's put this value in this. Suppose this is equation 1. So put the value in equation 1, you will get the answer. So here this will be mg upon A plus P naught, which is atmospheric pressure, plus rho g HA plus half rho VA square is equals to P naught plus half rho VV square. Okay, now P naught get cancel. Again VV, that is equals to V, which we need to calculate. Then what is about VA? What is the velocity of water that is coming down towards the pole? So here this term is again missing. So just try to find out what is VA. So if we find the area, to find out, just go to the equation of continuity, which tell you the relation between area and velocity. Your area, both the ends is given, velocity of one is given. So what is the velocity of this top one? So if we check the equation of continuity, that is the area at A multiplied with velocity at A is equals to area at B. Let's say this is A and the velocity at B, that is equals to B. Now area, this is given as area of this given as 0.4 meter square. VA is equals to, this area is just 1 centimeter square. So just convert it into meter square, that is equals to 10 to the power minus 4, and this is equals to V. So what is VA then? VA will be 10 multiplied by 4 upon 0.4. So if we'll check this, this term is very small. So this VA can be neglected. So this term can be neglected. From the equation of continuity, if we go this relation, that is area multiplied with velocity is equals to area multiplied with velocity, you can find out the velocity of at this portion, which is very small. So just neglect it. Now coming to this question. So what is VV? That is equals to, I am writing one more step, that is half rho VV velocity is equals to, denoted in the question as V square, is equals to, only this term is remain, that is mg upon A plus rho g h A. Okay, so this is V square. V square will be 2 upon rho will be multiplied with both this term. So this will get, you will get 2 mg, that is A upon rho, plus 2 g h A, rho will get cancelled. So this is the term V square. Now what will be V? V will be square root of 2 mg A upon rho plus 2 g h A. Ensures. Okay, now this is the expression of velocity of water that is coming out from the inlet B. So what is V now? Just put all the all the values. Everything is given. That is 2 weight. That is mg is given. That is equals to 20. Mass is given 24. Then g is 10. Area is given 0.4. Density is 1000 plus, that is equals to 2 multiplied with 10. Height is equals to 40 centimeter, that you can write as 0.4 meter. Okay, so just go and solve it. You will get the answer, that is nearly equals to, answer is coming as 3 meter per second. So check it whether you are getting the correct answer or not. Just put the values and solve it. Okay, so this is all about today's lecture. If you have any doubt in any of this portion, any question, any topic, you can reach out to me. The details are given in the description box. Thanks for watching PhysiCutor.